I guess having been in solar more than 30 years, you had to be optimistic, at least for some portions of the time as those years have gone by. I'm here to talk about what's happening with thin film. I'm really delighted to see such a large crowd here because I think it's a reflection of the scaling of the industry and the speed with which the industry is scaling. It's a little bit difficult in thinking about how fast the scaling happens, how the world is changing and has come to recognize the importance of clean energy. So we're a publicly traded company, and as an American publicly traded company, I always have to give a safe harbor statement that gives a caution about forward-looking statements and jumping off the deep end of the diving board into whatever new business areas there might be. To give a little bit of a background about Applied Materials. Applied Materials is a company that's been in business over 40 years, primarily involved in making equipment for making integrated circuits. And in the last 2.5 years has entered into the solar business space. It's a great company to be with because this vision statement is something that I didn't have to change when I joined the company. It's a company that is looking for a way to improve the quality of people's lives. And it's not just a slogan, it's something that we practice every day. We have solar power on almost all of our facilities. We're well along towards putting 2 megawatts on our facilities in the US and our other international operations as well. We have about 14,000 employees in the company. Now there's over 1,000 employees working in the solar business group, and we're growing very rapidly. Part of the ability to grow rapidly has really been a result of having people who could move from the integrated circuit business in the solar business. Saved a lot of time looking out to recruit people, for teaming, for building up the capabilities. Most importantly, what we're about is making equipment for people to make low-cost solar panels, thin films being sort of the speedy jump start that has brought us all here today. I'm part of a group called Energy and Environmental Solutions. We work not just on solar, but we have equipment for other kinds of technologies, energy efficient glass coating equipment. Last year, our glass coating equipment processed over 1.4 billion square feet of glass with low-E coatings. And we're in the equipment making business for energy efficient lighting as well. So the company is not only looking at solar, but looking at a whole panorama of clean energy possibilities because we see this as a huge growth area and a timing which matches the world's need for clean energy as well. From the standpoint of why would a company like Applied Materials be interested in this space, it's pretty straightforward. Having been involved in making equipment for processing wafers of silicon, and those wafers of silicon keep getting larger and larger, which has helped drive down the costs. The ability to control very thin layers and to control the material processes, the chemistry of the layers, the composition, and interplay with the tools used to make the layers, allowed the company to participate in the transistor revolution, where the cost of making a transistor since the mid-70s has come down by a factor of over 20 million. We also, as one of our business units, are in the equipment making area for large area flat panel displays. In just the past 10 years, the cost to make a big screen TV has come down by more than a factor of 20. If you think about what we need to do in solar, we just need to cut the cost by 2. We ought to be able to do this. We ought to be able to do this quickly. We ought to be able to do this with scale. And that's why Applied Materials has entered this space. We have both thin film equipment, which is what I'll talk about today, but we also have equipment and tools for processing of crystalline silicon, which is a separate talk that I'll give during the Intersolar show. So all of the technologies are accelerating in cost reduction. Part of that has been triggered by First Solar's great success in the past year, where in the last quarterly earnings statement, they talked about being able to get the cost of a solar panel down below $1.25 per watt. That means that everybody needs to innovate. It means that the technology has to change for keeping up with the competition. And there's a lot of great competition here, which is helping to fuel the cost reduction that's happening. What distinguishes what we're doing is the adaptation of equipment from the flat panel display business to solar. So coating a big sheet of glass the size of a garage door in the US, a little bit more than 60 square feet, 5.7 square meter size of glass, uniformly with a semiconductor layer is what it takes to make the transistor circuit that goes on the back panel of a liquid crystal display TV. Typically, this size of glass is used to make about 4 or 6 42-inch big screen TVs. And that piece of glass, of course, is getting even larger with the scale-up that's happening with the market demand for equipment that came about as a result of the industry for flat panel displays, for computers, and for televisions. In solar, what's happening is that we're able to make use of those tools that somebody else already worked to figure out. Somebody else has already built over 600 of those big screen processing tools, run them in the field. We have over 3,300 scientists and engineers working in the field who support the equipment being used for either processing integrated circuits or the big screen TV production. Those folks are there who can help also support the scaling that's happening in solar today. That glass coater that I was talking about for energy efficient glass, that's used for the front and back contact of any thin film. And it's used for the silicon nitride, the anti-reflection coating, or the passivation layer of crystalline silicon. So there's one tool which can service all sorts of different semiconductor layers. That helps drive down the cost of the equipment, improves the reliability, the maintainability, the serviceability of that hardware. Those have converged at this time because one big screen TV making tool, making a single junction of amorphous silicon, has a throughput of about 50 megawatts per year. 3 years ago, there was hardly anybody interested in a manufacturing line that processed 50 megawatts in 1 year. Today, almost everybody needs to have a manufacturing line of that scale. So equipment from these other areas is coming about and helping us all to be able to lower the cost of making a solar panel.